Yeah, for those of you that have been wondering who's this funeral director walking around here, yeah, that's me. And yeah, I am a construction safety guy, even though I'm obviously overdressed. My name is Tony O'Day. I'm Vice President, Director of Corporate Safety for Gilbane Building Company. We are the oldest and largest family construction company in the country, 141 years young, with lots of exciting projects here in Florida. I'm just so pleased to join you today. I want to thank the Alliance for Central Florida for Safety for the opportunity to be part of this impressive conference. I want to thank, obviously, Michelle for her support in our relationship at the Disney project, and hope you're all having a great conference. And most importantly, I want to thank each of you for your dedication and effort to protecting the lives and the livelihoods of everyone in our construction projects, our workplaces, our facilities. Thank you very much. So well, Timmy, we gotta get this started here. Bear with me. Okay. Very good. So at Gilbane, we start every meeting with a safety moment, and I'd like to share with you something that's personal and relevant to me and relevant to the topic that we have here, we're going to be presenting today. So as many of you have heard from CNN, or maybe your friends or family that live in New England, we had Snowmageddon in, in Massachusetts. I had 110 inches of snow that fell on my roofs. And it was so disruptive for the economy. We had 120 buildings collapse because of the weight of snow, and we had frantic property owners sending people up on roofs to clear snow away from heating units, exhaust fans, and just trying to remove the weight of the snow. And unfortunately, as a result of that, 6 people fell through skylights in February alone. So it occurred to me, on my roof, I have skylights. What would happen if a firefighter looking to rescue my family were to fall through and get injured or killed because he didn't know where my skylights were? So despite the almost daily snow, I made a concerted effort to remove the snow and make the skylights more conspicuous. But then I started to ask, why? Why am I doing this? And I started to do a little research. I discovered that every year, 50 people fall through skylights in workplaces all over the country, and 36 people are killed every year. But the amazing fact is, skylights in the US are not required to support a person. Now, there are skylights, Velux, Wasco, that do make skylights that will support a person. But in Europe, this is required. So the bigger why question is, why we as owners, designers, and contractors, when we replace skylights, when we specify skylights, why don't we care enough to replace them with skylights that will keep people from falling through them? And that was my aha moment, which brings me to the topic today. We're going to talk about how owners, builders, designers, and operation and maintenance personnel can work safely by design. So my goals of this presentation are, one, to give you an understanding of the impact that prevention through design can have in your construction and design decisions. I'm going to help to recognize the armed hazards and threats that could be designed into your buildings that you're working in or constructing. We're going to learn how we can leverage technology to improve the efficiency of construction projects, also known as lean, and the resultant safety benefits. We'll also share what the industry is doing, what regulatory agencies and other associations are doing to move the needle for prevention through design. And we'll give you some, I think, important and useful resources so that you can integrate prevention through design into your operations. Sounds interesting? Okay, let's go. Prevention through design. Now, when I talk about design, and I need to point out, so I'm a civil engineer, right? So, I'm not anti-engineer and I'm not anti-design. But when I talk about design, I don't necessarily just mean the design of the structure or the architecture. I'm talking about the design of the process. What we as construction professionals do to set up our construction projects for success. Prevention through design is a moral imperative. And here's why I say that, right? Every year, 4,400 people die in workplaces. Studies in the US and Europe on an increasing basis are determining that 40 to 60% of those deaths were the result of decisions made in the pre-planning and the design process. That's 1,700 to 2,700 workers no longer on this planet because of what we're going to talk about today. And what I propose is that prevention through design is also the smart thing. How many safety professionals in the room? Sure. So I'm going to hazard a guess that you, like me, operate in the space toward the right of this graph, right? You have incidents, injuries, near misses, so we mobilize resources, we devote our time and attention to right the ship, and we have just only small increments of improvement. What I contend is what we'll talk about today moves that to the left of this graph. We have far greater influence, and we spend much more capital if we prevent these incidents by the design of our processes. And we'll provide some examples for that. Building owners and designers frequently make uninformed mistakes when they focus exclusively on the cost of a construction project and ignore the life cycle implications of the design on their operations. Life cycle cost analysis experts have studied the ratio between construction cost to the operation and maintenance cost of a building over its 50-year cycle and determined that 60 to 90% of a building's life cycle cost occur after construction. So is it financially smart to focus on the design elements that could result in improvements and safer environments for your user groups? So let's go through recognizing some of these what I call armed hazards or threats. So look at the picture on the left. Right, the proximity of that air handling unit to the roof. So what's the likelihood in the 50-year life cycle of the building, as maintenance people and technicians go up to service that unit, change out the filters, that at some point somebody's going to slip and fall off the roof? Or the picture on the right. That's an elevator machine room without the walls erected. So imagine an elevator technician having to work in that with unguarded shivs, exposed wiring. What's the likelihood that something terrible will happen in the course of servicing the elevator? These are designed by professionals. So picture on the left. What's the likelihood that some distracted walker texting and walking, right, like that never happens, or a child or somebody walks into that bollard and gets injured, and the property owner is going to own that injury, right? The picture on the lower center is a gas line that was installed across a designated walkway on a roof. What's the likelihood that a service technician or maintenance person at night or in snowfall, where that line is obscured, trips over that and falls onto or sadly off the roof? The third picture is a picture I took on a courthouse, state-of-the-art courthouse we built in California. There are 6 recessed light fixtures 40 feet above the floor. What's the likelihood that those bulbs are going to get changed? And what you don't see is the floor is a sloping floor at the bottom. Those light bulbs will never get changed in the life cycle of that building, I guarantee it. And then, of course, the picture on the right. What's the likelihood that a firefighter isn't going to strike his head, in the effort to try to get to the roof with a building that's obscured by smoke? Again, these are armed hazards designed by professionals. Some more. How does an operation or maintenance professional maintain the safe operation of the system if they can't even read the valves, or can't even access them, or the gauges? How many have been in this situation? The event that this picture was the source of was an accident investigation. So we had one of our craft workers, after we had constructed this part of the roof and threshold and curb, trip and fall and break their arm on this detail, which we're going to leave for the owner because that's how it was designed. What's the likelihood in a 50-year cycle that there won't be more broken arms because of this detail? So these are the armed hazards that I'm talking about. And, again, be aware of these in your projects, in your facilities. This is a high-rise in New York City. Notice the smooth concrete treads, the lack of tread markings. So what's the likelihood in the event of a fire as panicked people are running down this stairway, which is made slippery by foam and water, and firemen are running up the stairway, that people don't trip and fall and cause, major injury and worse? Owners and designers need to ensure that the cost of a worker failing to use precautions around their design is not going to cost their life. So, prevention through design may be new for most of you. Do you know what the oldest prevention through design directive is? Anybody a student of the Bible? Deuteronomy 22:8. Moses was giving the book of the law to his people, and the Lord had given him this directive. When you build a new house, you build a parapet on the roof so that you won't suffer blood guilt onto your home should someone fall off. Yeah, look it up. So the picture on the left is a parapet, 42 inches high, right? Prevents falls for both the construction workers and the operation and maintenance personnel. But many times you can't design in a parapet. So we do the next best thing, right? And we try to influence the designers to put in stanchions for fall protection. But human nature relies on the fact that someone's going to tie off to that. Human nature, being what it is, people tend to look over the edge when they're on roofs, don't they? We got to make sure that our controls don't require someone to have to make the right judgment to tie off, because chances are they probably won't. So this is a courthouse that we built in Massachusetts, and we were able to influence the designer and the public agency administering this project by alerting them to some armed hazards that were going to cause problems for their end users. And we were successful in persuading them to install some of these fall protection devices. For example, these stanchions running parallel to the roof edge and around the equipment. So at least people had the ability to use personal fall arrest. And of course, we recognized that there were some mechanical units on the standing seam roof, so we were able to alert them to this hazard. And again, a cable was installed from the roof ladder across the standing seam roof. And then, knowing that this building had a lot of windows and eventually would need maintenance in terms of caulking and things, we were able to persuade them to install a trolley system, which we were able to use during construction to support window washers and other maintenance people that might be on the exterior of the building. But the key is being able to recognize these armed hazards and then having influence, as we showed in that graph at the beginning, right, to try to mitigate those hazards. So let's talk about building information modeling. So BIM has evolved so much further than merely being able to look at how utilities clash. Right? Presently now, we can use building information modeling to visualize all aspects of the construction project, from the structure to the excavation, all the equipment that supports it, concrete trucks and cranes, and determine how best to organize our project and support our workers in safe and efficient work. Our vision for BIM is that we can leverage this technology to anticipate predictable hazards through the visualization enabled by BIM and have a more informed dialogue with owners, general public, clients, and our subcontractors, right? To look for those impacts and those interfaces, right? And prescribe those corrections early on in the process while we still have the ability before the first shovel hits the ground. So those of you that are into construction, you might recognize all of these particular site constraints that we have to worry about in construction. Historically, the only way you could try to anticipate predictable hazards was to look at a two-dimensional drawing, what I call old school. Now, through BIM visualization, you can fly through and walk through the model. Right? You can determine how best to bring material in, where to store it, how to move people in and through the project, what particular impacts you might have on adjacent client and property owners. Use it to secure permits, right? Get safety plans approved. You can have, again, so much more effective dialogue. And all of these constraints and pinch points that you encounter on a project, you can address early on in the process through the use of BIM. So let me give you another use of technology employing BIM. Prefab and pre-assembly. And I'll give you a case study. So we did this $100 million lab facility in Massachusetts, $40 million mechanical, electrical, plumbing package. It was a design assist, not a design build. There was a designer of record. And there was no special integrated project delivery or IPD language. So there was no contract language that required us, as integrated project delivery does, to come together and support each other in these design decisions. So essentially, it was like most other construction projects. Here's your contractor, you go build it, find the subs to do the specialty work, agree to this maximum price. That was, pretty much construction manager at risk work. And so we sought a way to leverage technology to improve the efficiency, because it was just a crushing schedule and a postage stamp of a site. So here's how we tackled that, and I'll tell you the results. We had a BIM-enabled architect, which then allowed us, through our contractors, spatially identifying, through the use of BIM, where all the utilities were, where they would fall in relation to the beam penetration. So we were able to send our BIM drawings directly to the steel fabricator, who made all of the beam penetrations in the shop before they arrived on site. Just imagine the hot work saved, the fire risk avoided, the unhealthy fumes created, just the logistics of having to do all of that work amidst other contractors. And then because we knew through BIM where the utility piping is, we also knew where the hangars were. So we were able to lay out the hangars on the concrete deck before the slab was poured, right? So that all of the the embeds for all the hangars were already installed, avoiding, tens of thousands of excursions up ladders, ergonomic, postures, drilling overhead, the silica dust and health hazards, avoiding all of that by being able to lay that out on the slab and have that all ready for installation of the mechanical equipment. The other thing we were able to identify was opportunities to pre-assemble sections of our piping. Again, as the slide says, we had 180-foot corridors. So what we were able to do was find a fabrication shop near site. So we employed local labor, right, and brought all the trades together in a well-lit, environmentally controlled, ergonomically friendly, tables, overhead cranes, to put these racks together, layered with all of the electrical and plumbing and mechanical, and then, as you can see, crane them into the building. So what would have taken 2 weeks took 2 days. And we did that repeatedly in the project. The amount of real estate we maintained on the project, because conventional construction would have all that material sitting on the floor and then piecemealed. We need to think about construction differently. If we built my Ford pickup truck the way we build buildings, it would take me 3 years to get it. Think about it. In construction, we build the steel, then we pour the concrete, fireproofing, then the mechanical, and then this has to be installed and that has to be installed. It's sort of tantamount to building a truck by saying, all right, well, first we're going to build a drivetrain, and then when that's done, then we're going to come over here and start creating, working on the wiring harness. All right? Then when that's done, we'll do the chassis. Right? We got to do what the auto industry does, right? Find ways, right, to do these things on the same parallel path so that just in time everything comes together. So while we're still pouring concrete, we're fabricating mechanical equipment. Other opportunities we saw, these coil packs, right? Dozens of wells, hundreds of them. And again, we were able to pre-assemble them off-site, saving excursions up ladders, fires from hot work, et cetera. So what was the result? So we did this project, which had an incredibly compressed schedule. We worked 500,000 hours without an accident. We shaved weeks off the schedule. We saved 10% on the budget. And in a $100 million, zero punch list, as it says, in a $100 million R&D facility, we had one change order for $3,000. This works. And the project was absolutely immaculate, because all of that material didn't have to show up on the project. So part of prevention through design is challenging convention. We had a border station to build on the US-Canadian border during this terrible winter we had. And we were faced, because of the schedule, with having to build this roof in some pretty severe weather. So we got with this local contractor and said, well, can we build this roof on the ground? So they'd never done it before. Again, we're challenging convention, but they said, all right, well, if you'll support it, we'll figure it out. And that's what we did. And you can see the testimonial from the contractor. 30% faster, not to mention safer. So part of challenging convention is this idea of we've always done it this way. So think about this for a moment. So think about concrete and masonry, and the challenge we all have of protecting workers from impalement, bumps and scratches caused by vertical rebar. And so what do? Right? We cap all the rebar, and then the very people it's designed to protect take it off just before they're ready to form the wall or lay the block. So we asked this worker, why are you removing the protection? It's designed to protect you. We've always done it this way. We said there had to be a better way. candy caning rebar, and I'll talk to you about this in a moment, but removing the impalement hazard in the detail shop. Isn't that unconventional? First, we had to do a study to prove that it was worth the effort. So we took all the conventional rebar protection devices that were there, the Carney caps, shown on the left, the standard rebar caps, whether they be mushroom or metal embedded, doesn't matter. Looked at those, labor intensive, of course, right? Always falling off. And we looked at troughs, but again, labor intensive, material intensive, wasteful, not applicable for every situation because it presumes that the rebar is at the same elevation. So we had the opportunity to work with a strategic partner, a subcontractor, Baker Concrete. They're a national concrete company, and I know they've built some projects here in Florida as well. And so we had an opportunity. We were building a new engineering building at Ohio State University. And we wanted to try out this idea, this get bent approach, candy caning rebar. But again, we had to prove that it was worth it. And we discovered that there was virtually no cost to doing this unconventional approach. In fact, the detailers, the rebar steel detailers, pretty much said, it's just one more bend for us. You know, it's in the process of being bent, and you know, it's just one more bend. It doesn't cost us anything. Imagine how many of us chase our tail with rebar caps and rebar protection, and the time and the wasted effort solved. Unconventional ways to design hazards out and work safer by design. Now, we don't have a monopoly on this. The American Institute of Steel Construction actually had a brilliant idea. Well, let's go ask our stakeholders, the iron workers, who have to build to our detail. And so they did, and the iron workers said, you know, one of the most challenging and dangerous connections that we make is a column splice. Now, the AISC had designed the most efficient column splice structurally that they knew, and that was make a column splice 2 feet from the floor above. But what that required was iron workers to set up extension ladders precariously on corrugated metal deck, right? And then have to take their hands off the ladder to tighten the bolts. Extremely dangerous, cause of many iron worker accidents. So by getting stakeholders together and working through this, the AISC proudly published a standard detail that is now used nationwide, and it's called the erector-friendly column. It puts the column splice 3 feet above the deck. So all of that work is done with boots on the metal decking. And in addition, it pre-punches the standard guardrail holes at 21, 42, and 7 feet if personal fall arrest systems are going to be used. Saving all of that danger and risk. Again, all part of designing it into the process. So I brought these props with me because I'm sure you probably haven't ever seen them. Any electricians here in the room? Okay. So what do you suppose the most frequent source of injury to electricians is? Shock, arc flash. And you're right, that's the most serious. But you know what the most frequent injury to electricians are? Hand lacerations. Believe it or not, hand lacerations. Why do you suppose that is? Sure, I see people, using utility knives, stripping wire, putting their hands into metal boxes. Has anybody been a handyman electrician around your house? Those metal boxes are sharp. They're raw-edged. We said, there's got to be a better way. To just keep seeing electrician after electrician lacerating their hands, and gloves aren't necessarily the answer. So we looked at these plug tails, and they're commercially available. And they use a tail that basically plugs into the back of your switch or your outlet. Right? Pre-cut splice, right? Simple to do, right? No need to work inside the box. Make the splice outside the box, tuck it in, plug it in. Takes 2 seconds. But again, we had to prove this. So we did a study. And we looked at the expense of a plug tail versus conventionally installing receptacles. And yes, while there is an initial cost, the fact is with a plug tail, even a journeyman electrician can install these, or even an apprentice. I mean, they're fairly easy to install. So you have a lesser pay grade, if you will, but most importantly, you can install 10 times more of these than you can conventional receptacles. Right? So that productivity alone saves you labor. So for 1,000 devices, even with the expense of 1,000 plug tails, you save $3,000. Right? Challenging convention. You know, if you haven't checked it out yet, I would encourage you to go to the SawStop exhibit. It is a great product, and it is a great table saw. So the first serious accident I ever experienced, I was a young 20-something superintendent, and a foreman burst into my trailer, holding the finger and thumb of his also 20-something apprentice who had just cut it off with a table saw. They didn't teach me that in engineering school. I didn't know what to do with that. That still haunts me. There's a better way. If you've seen the SawStop YouTube videos and the hot dog that runs on the, sure, right? One SawStop compared to the litigation, and these are all actual numbers from a claim involving a table saw. Do you know there's over 31,000 table saw accidents in this country every year? And in 2005, the Consumer Product Safety Commission, in an effort to try to stem the tide of all these terrible injuries, issued a directive that all new table saws would have a new rive blade and a modular guard. You know what that did to table saw injuries since it was enacted in 2005? Nothing. Same amount of table saw injuries. Right? This is where the industry needs to go. New, safer equipment. And when it engages, I'm sure the SawStop rep will tell you, $70 to replace the whole mechanism, compared to a loss of a finger and a loss of a livelihood. Here's something you probably don't know, I would guess, because I just learned it myself. Do you know the greatest source of lead hazards on your project is a source you're probably not even aware of, your powder-actuated tools. Look at the MSDS sheet on your powder-actuated tools. They either contain a significant amount of lead strontium or lead stiphanate, lead. So our insurer, Liberty Mutual, decided to do a test. So they put personal air samplers on a bunch of drywall framers and just had them shoot track on the floor. After 100 shots, the amount of lead in the individual's breathing zone was above OSHA's action limit. 100 shots. You could do that in less than an hour. Not to mention the lead dust that was on their hands that they ate with, or on their clothes that they hugged their family with when they returned home. Sure. This is the next sleeper injury or illness. There's a better way, though. Ramsett and Hilti make lead-free boosters with no impact on performance. You know what the lead does? It doesn't increase the boost. What happens is when the lead explodes, the lead dust becomes like graphite. It lubricates the barrel. Really? There's got to be a better way, right? And these products are available, and they're not that much more expensive. And you can eliminate the lead hazards on your project tomorrow. So here's a great idea that was in advance of regulation. So the asphalt industry recognized the dangers of asphalt fumes and realized that OSHA was getting ready to come up with a notice of rulemaking for regulation. So the asphalt industry got together and decided that, we got to clean our own house here. So they explored different ways to lay pavement. And lo and behold, they discovered if they didn't heat the mix up quite so hot, it wouldn't generate half as many asphalt fumes. And they wouldn't use as much energy. But they still had a product that performed exceedingly well. And even better, you could get on it quicker. Right? It didn't have so much cooling time. Right? So they tried this warm mix asphalt experiment, and now the use of warm mix asphalt has gone nationwide. It's gone up exponentially because people have discovered there's no reason to heat asphalt to the temperatures they were heating it at and causing health hazards for the paving workers and spending all this energy. But there's a case where the industry got together, recognized the problem, and try to find a way to work safer by design. So I want to talk about additional contract provisions. Sorry. So I'm a CM. I live and die by the performance of my specialty contractors, right? Our contractors, they buy specifications and plans, right? And that's what they own, and that's what they bid on. So if I want these requirements, I need to specify them, because as I say in there, what gets bought gets done. Some of these things that you've seen have to be spec'd. If I want a saw stop, I need to require a saw stop. If I want plug tails, it needs to be in the contract. But that's how you make that happen, is in these additional provisions. For example, picture on the left, taken outside of Oakland Airport, one of the busiest airports on the West Coast. Notice the pedestrians almost coming in contact with the fence supports. So what happens at night? There's no lights. Somebody trips and falls on that. The contractor, owns it, owns the injury. So, we got to think beyond, well, this is what the fence company has to provide. This is what convention tells us, right? Additional provisions can say something like we specified here. Fence posts shall be either driven into the ground or supports, or will be self-supporting where the supports don't lead into the passageways and accessways. Everybody ever been to Manhattan? A lot of you might have. These are everywhere, right? These scaffold covers, right? And of course, the New York Department of Buildings requires if you're doing any work on the roof, you need to build this at the pedestrian level. Do you see any hazards associated with this? I mean, it looks pretty substantial, right? But in the winter we just had, you've got to shovel it, you've got to sand it, you've got to salt it, you've got to light it. And then most of these are on sidewalks in proximity to roads. What if a distracted driver drives into one of these things? I mean, people could get killed. What's the better approach? Well, if the hazard's up on the roof, right, put the protection on the roof. For a fraction of that cost to erect that and maintain it, right, you can build something like this on the roof. Keeps workers safe, keeps material inside the roof. but there's a building code that says it must look like the former picture. Right, so we need to challenge convention and then prove that it can work. And you'll see my subtext here is what's in it for me, right? Because with all of these, right, ultimately you need to persuade people, convince them. You got to demonstrate what's in it for them. So the picture on the left was taken at the Natural History Museum of a ladder that was constructed 10,000 years ago. The picture on the right was taken 10 days ago. Not much different. Now, it meets the ANSI 14.1 standard, sure. Right? So I saw this worker, right, climbing up the job-built ladder with a tool in his hand. But can't do that. You got to make three-point contact. So well-intentioned person says, well, just drop a rope. How many of you have heard that solution? Drop a rope at the ladder. Have you ever seen 200 workers try to go in to the building with tools and stand at a job-built ladder while ropes are going up and down? You can't impose solutions that aren't workable. You lose credibility, and you have no chance of it being, being followed. And then you set up for non-compliance. So what's the solution? Right? Take the stairs. So we've required in our safety program now that we will not allow job-built ladders for site access. And we're a construction manager, so that's what we own. We own, sanitation, site access. We need to provide the conditions for the workers for, safe and efficient work. That's all they want. And so we just specify whether they be scaffold stairs or stairs like these. And workers appreciate that. They work more efficiently, they work more safely, right? And we don't set them up for failure by setting up ladders and then wondering why they don't make three-point contact. Right? So when you talk about prevention through design, if you want to be heard, you got to use the language and vocabulary of productivity, right? And safety will follow. So you look at this example. Now, notwithstanding all the time and effort and money it took to build that scaffold, there's still 2 or 3 violations that I bet you all could probably pick up. Right? The cheapest, most productive thing to do is use a lift, right? Use the language of productivity, and you'll be successful selling safety. And then, I've had to learn this in, 30 years of construction. Right? You got to have alternatives. You got to have solutions. We can't just be the safety professionals that say no all the time. Now, part of that means we need to be well researched. We need to study and see what new devices and products are out there, and introduce people to those. Because, most construction people want equipment that's cheaper and faster, and but there are innovators out there. And so if not ladders, then what can we offer? So what are our opportunities? If you're an owner here in the room, right, ask your designers about their experience with prevention through design and grade them on that experience. Create additional provisions in your contracts with your general contractors so these things get bought into the contract. Okay? Hold your general contractors and your construction managers to these safer alternatives. Right? And look for those armed hazards that might be in your building and challenge design professionals that have provided risk for your users. Any insurers in the room? Sure. So, right, train your people on recognizing these armed hazards. Right? Introduce these prevention through design ideas, right, with your insureds, right? And, talk to designers. because ultimately these are going to result in claims later on that you're going to be paying for. Again, back to that curve, our influence increases and the resources we spend decrease the further upstream we go. And then GCs and CMs, right? Use these additional provisions, recognize those contractors that integrate prevention through design techniques, right? Prefab, pre-assembly, reward them with contracts, reward them with recognition, okay? So, lastly, I'm going to provide you some resources. I know I'm getting close to time. Thank you for bearing with me, by the way. So these are the thought leaders of prevention through design, right? These are our current Einsteins, Teslas, Edisons right now, okay? Moving the needle for prevention through design. And I'll show you what each of these websites represents, so you have some tools. Interestingly enough, prevention through design was first mentioned by the National Safety Council in 1955 in their accident prevention manual, and then never a word was said until the late Dr. Jimmy Hinsey, University of Florida, go Gators, and John Gambates in the 90s did some research to determine the efficacy of prevention through design. NIOSH took on that research and made it part of their national agenda. So NIOSH is now looking for partners that are exploring and using these techniques and posting case studies to move the needle of prevention through design forward. And this is NIOSH's website. The Prevention Through Design website is also a great resource to let you know what's on the cutting edge of PTD, where the courses are that you could take to learn more about this, right? Design guides, a whole lot of resources in that website. In the UK, a group of EH&S professionals, attorneys, academia, designers all came together to create design guides for each aspect of construction and building component, so that contractors can use these guides to create effective job hazard analysis and identify these armed hazards to mitigate them. The Design for Construction Safety Toolbox is an interactive program where you can put in specific activity and it'll tell you the hazards that you're likely to encounter and how to mitigate them. And another interesting interactive program is a slide rule. So through slide rule, you put in a particular activity and quantity, and slide rule, so let's say I'm going to install 150 linear feet of 8-inch pipe, cast iron, 10 feet in the air. Slide rule will look at the frequency of accidents, the potential severity, and the exposure. It'll come up with a risk rating. The lower the risk rating, the safer the design. Again, it's available online. It's an interactive program. And then lastly, and I'm most excited about this one, how many people have had to build a project to LEED, gold, silver, right? Okay, so maybe a quarter of you, a third of you in the room, right? So the U.S. Green Building Council has a LEED rating, right, to design and construct buildings in a sustainable way, focusing on recycling, energy efficiency, et cetera. And so you fill out an application, right, where you take, the elements of how you constructed a project and its design elements, its energy efficient elements, right, and you get points for these various things. And depending on the number of points, right, you can apply for and obtain, right, a LEED rating. And these are jealously guarded. I mean, our owners, our clients, brag about these, and the people that work in the facilities are proud to be in a LEED facility. Well, the problem with this recently became transparent at the construction of the City Center in Las Vegas, where 6 beautiful facilities were constructed, all emblazoned with these big plaques on the side of them, gold and silver LEED, and 6 people died in the construction. And so we realized there's a disconnect. You can't talk about a sustainable project and hurt and kill the people in the community that built it. So the US GBC has finally issued, this is hot off the press, within the last month, you're probably the first to hear about it, a pilot credit. So you can get an innovation credit if you're a designer, and you've worked on introducing design ideas that eliminate hazards, you can submit and get an innovation credit. If you're a construction manager, right, and you implemented certain elements of your safety program that has eliminated hazards and you can show that, you can get an additional point on your LEED certification. Right? The USGBC and NIOSH have asked me to ask you to start using this credit. This is a pilot program. They're floating it out there because they've heard this hue and cry from industry that this is what we want. The only way they'll know is if they start seeing a flood of applications. So, look into that, see if it's applicable to your projects, and be the trailblazers. So in conclusion, right, I think we've given you an understanding of the impacts of prevention through design. We've taught you how to recognize some of the armed hazards, showed you ways to leverage technology to improve the process, and we've provided some resources as well. So I hope we've accomplished what we set out to do. Do you have any questions? I know I'm imposing on your time. Yes?
That case study at the beginning with the pre-fab.
The case study, yes.
How much time did that add to your pre-construction?
That's a great question. It did. It added, it added another month or two of the pre-construction, but we more than made up for that in the schedule reduction. And the fact is, most construction projects take some time to develop, in the process of letting out the contracts and developing what the user groups want. So there's always sort of that, I don't want to say unproductive time, but time that could be better used. And we were fortunate. We had an owner who was progressive who said to their architect, all of this design will be in BIM. So we had a great starting point. So once the design was in BIM electronically, our contractors only needed to provide their drawings in BIM as well, and the owner paid for that. But what they got in return was significant savings and certainty of function. But thank you, great question. Yes, sir.
Does your three-dimensional BIM modeling calculate structure loads, design loads?
That's a great question. There are new capabilities being designed. There's a BIM 360, for example, that has contained within it a lot more functionality, so the technology is just exploding. I mean, I don't even claim to understand it anymore. I couldn't figure out my phone. I gave it to my 9-year-old grandson, and he programmed it in 2 minutes. I can't understand it, but there is that capability, sure. The exciting thing is all of you have the ability to look at a BIM model on your computer, and all you need is a free bit of software called Navisworks Freedom. If you've got that software, someone can send you a BIM model, and you can literally fly through and walk through the model and be much more informed about the project before a shovel hits the ground. Thank you all so much for your generous gift of time. Thank you.